Okay, in this video I want to look at a neat kind of problem that we can now solve using polynomial division, this new technique. And it's this problem, solving a cubic equation. In the past we've solved cubic equations, but it was always when it happened to be one that you could factor using factoring by grouping. And it turns out if you try it, x cubed plus x squared and negative 10x minus 12 don't have a common factor, so we can't use factoring by grouping. We need some other method. And so what might occur to you to try and solve this is just use kind of a guess and check method. If we plug this into a graphing calculator or a graphing utility online, then we can come up with a graph of the corresponding function, x cubed plus x squared minus 10x minus 12. And when I look at the graph, I'm looking for my x-intercepts because it says this function equals 0. So function equals 0 means I'm right on the x-axis. And so if you look at it, I see there's 3 solutions. So we should be getting 3 solutions. There's 3 places that I am hitting the x-axis. One seems to be at 3 point something. One seems to be at negative 1 point something. And the last one is right at 3. Right at negative 3. And so that's actually a very helpful piece of information. The fact that I know one of the solutions means that I know this guy must be able to factor, and he must have one of his factors is related to x minus 3. So I think what I can say is that this x cubed plus x squared minus 10x minus 12 is equal to, let's see, what would it have to look like if it had an x intercept of negative 3? It would have to look like x plus 3 times something. I'm not really sure what this something is, but I think that this guy has to factor as x plus 3 times something. Because then if it did factor, x plus 3 would end up giving us our x-intercept of negative 3. And so if I'm trying to figure out what is this something, I can use polynomial division. Divide both sides by x plus 3 to solve for this unknown polynomial. And so that's what I'm going to do, is I'm going to use polynomial division to figure out what's the missing piece. Okay, so let's run through this and then hopefully it'll make a little more sense once I can actually stick something in there. For now, just bear with me. We're going to try dividing this big guy by the small guy. So x plus 3, I'm going to try and divide that into x cubed plus x squared minus 10x minus 12. So x into x cubed, x cubed divided by x would be x squared. Oh, let's go ahead and put it on top of the other x squared. Again, not that it matters where exactly I write my quotient. X squared times this guy, x squared times x is x cubed. X squared times 3 is 3x squared. And then we're supposed to flip some signs. Okay, so let me pull out my handy red marker and flip all the signs. So it's a plus on the outside, and I'm distributing the plus to make the 2 signs on the inside both negative. So x cubed minus x cubed is nothing. X squared minus 3x squared is negative 2x squared. And then bring down your next number, which is minus 10x. Okay, same story again. Negative 2x squared divided by x would be negative 2x. Multiply negative 2x times both parts. Negative 2x times x. Negative 2x times 3. And then we do our flipping the signs operation. So this turns into a plus, and a plus. Negative 2x squared plus 2x squared goes away. Negative 10x plus 6x is negative 4x. And then we bring down the next term. Okay, negative 4x divided by x would be negative 4. Negative 4 times everything in the left. Negative 4 times x is minus 4x. Negative 4 times 3 is negative 12. We're supposed to flip some signs. My 4x's cancel. My 12's also cancel. Interesting. This is not a coincidence. There's a reason we picked x plus 3 to divide by. We wanted it to be something that divided in evenly. and now we know how it divides unevenly. X cubed plus x squared minus 10x minus 12 divided by x plus 3 is apparently just going to be equal to our quotient with no remainder at all. Which means if I multiply both sides by x plus 3, I get exactly this equation. Okay. So, using a graph, I was able to come up with a guess of one of the factors, which was x plus 3. Using long division, I was able to figure out what's the other factor, what do we multiply it by. And now I think I'm ready to apply this to the particular problem. So let's go back and see what this means in terms of the original problem. So the cubic on the left-hand side we said is now x plus 3 times x squared minus 2x minus 4. So I'm turning this equation into this equation just by rewriting the left-hand side according to the formula we came up with. It looks a little bit different than things we've seen before. When we're used to seeing an equation that factors, we're used to seeing like binomials in each. This is the first time we have a binomial times a trinomial equals 0, but it is still a factored polynomial equals 0. And so the only way for this to be 0 is if either the first set of parentheses is 0 or the second set of parentheses is 0. And this one tells us the information we already know. One of our x-intercepts is at -3. This other one, unfortunately, doesn't factor. If it factored, that'd be really cool. It doesn't factor. However, it's a quadratic equation, and nobody's ever going to stop me from solving a quadratic equation. I can always pull out quadratic formula. And so if I use the quadratic formula, I should be able to solve this. So even though the original problem has these 3 answers, and I have no good way of wrapping my hand around them, if I can find one, even just one solution, that means I can divide the big polynomial by whatever solution I come up with to make a smaller, simpler polynomial. In this case, I turned a cubic into a quadratic, and then when I turn it into a simpler problem, then hopefully some new avenues open up to me in terms of how to solve it. And this is, again, I can solve this using quadratic formula. So jump straight into that. X is equal to minus -2 plus or minus the square root of -2 squared plus 4 times 1 times -4, all divided by 2 times 1, which I think is 2 plus or minus, let's see, this is 4 minus, oops, sorry, need to write my quadratic formula down, right? 4 plus 16 over 2, which is 2 plus or minus the square root of 20 over 2, or, let's see, square root of 20 is really the square root of 4 times the square root of 5, and so we can write it as 2 times the square root of 5. And then we can cancel a 2 out of everything to make this 1 plus or minus square root of 5. And so we have 3 solutions, 1 plus square root of 5, 1 minus square root of 5, and -3. Okay. That was long. Let's take a second to unpack what we just learned. If I'm given a really complicated polynomial equation, and there's no obvious way to factor it, if I can guess one of the solutions, and there are some techniques we can use to guess. In this problem, I used a graph to come up with a guess. We could also just try guessing random numbers for x. I don't know if that's the best option, but there's different methods that we could use to try and guess a solution. If I can find any single solution, which means an x-intercept, then that's going to correspond to a particular factor of the polynomial, and I can divide the polynomial to make it into a smaller, simpler polynomial that hopefully then is easier to solve. This one ended up being a mess because it turned into a quadratic formula at the end of the day, but the same principle would still hold even regardless of what the degree happened to be, regardless of how complicated this was. If I can guess one solution, I can turn a complicated problem into a less complicated problem.